Hey guys and girls, welcome back to another beautiful video on this beautiful channel, on this beautiful day. How you guys and girls doing? Hope you're doing great as always. Please check out the description box for all the nice links. Also drop a like and subscribe if you like the content. So I apologize. I just want to start off by apologizing really for the last two videos. They've been kind of complicated. I haven't explained the shaders and things have just been kind of, hopefully it's just not been going too fast for you, hopefully, but I feel they have. And we added a bunch of things to a bunch of stuff and it just went so fast. So I'm just going to organize things together here. Players, entity, tile. This is pretty much the stuff we changed, all right? And I really recommend you, if you're here in this video series, really recommend you to watch the two previous videos again if you haven't managed to make it work. Also, I want to make sure you guys go into let's see, Chrome, go into your thing, go to GitHub. Let me just show you GitHub. Just go there. I uploaded the changes like this. All you have to do here is, I don't know what this is, you just go into GitHub/headturner like that. Okay, and you'll see the SFML RPG repository. I know a lot of you know about this, but for those of you who don't, just go in here. Okay, go in, get files from here. I do have all the resources, new tiles, new sprites, everything's in here. You can get the sheets, tile sheets as well. Tile sheet 3 is the one we're using now, and player sheet 2 is the one we're using now as well. And the background, there's a new background, BG2. You just can get all the resources. You can just download the whole resources folder here if you need that. What you can do is you could clone or download. So you can just clone or download the entire project and just copy over files if you can't run it directly from the downloaded file. And I really want to just stress, go in here, check the code to make sure your code is exactly like mine before you run it, okay? There can be small errors like a reference ampersand somewhere and it's giving you errors and you're like, what the hell's going on? Just make sure you copy code from here, or you at least look at stuff here. So you got the fragment shader.frag. You can just open it up. You got all the code here. Okay, you got the Vertex Shader as well, hopefully in here. Yeah, Vertex Shader at the bottom, right here. Just get that. And I'm going to try to explain this as well as I can now in this video. And it's just going to be the recap stuff because these things can be complicated and they can kind of mess you up. For example, in the tile.h, make sure your default values are in the h file here for shader null and the player position, and it's not a reference here. Make sure of that, and make sure it's a const. Anywhere where we added the vector to player position, you want a const, okay? And you add a default value to it. Now in the CPP file for tile, I just want to make sure that you don't have default values here. You just want them in one place, and that it looks exactly like this. So we're checking if the shader is loaded. If it's not null, then we're going to use the shader. Otherwise, we're not going to use the shader, and we're going to use the default one that SFML provides. And then you just send in shape without your own shader. Okay? Make sure these are set as well, and that you don't have typos here. It's very important, because if you look at this name here, these two names here, for any uniforms you wish to send in, these two, you don't have to send in a uniform for this, by the way. SFML does that automatically for the texture bound to the sprite. Anyway, these two names should be exactly the same as these. So you could just copy paste those basically to be sure. And then you're sending in the correct values. You want to make sure of that as well. The same thing in player.h. Make sure it looks exactly like this. These are the two new parameters, or the one new parameter here, the shader. And that you don't have a default value here. All right, remember that. And that these are the same again, and that you're giving it the center of the player. All right, because this is in turn gonna lead to the lighting effect. So you don't want that lighting effect to be off center. So you pretty much want this to be done. Okay, entity CPP. Let's just go through these things. This video is just for you guys who are having some issues. I just want to make sure it works. All right, again, go down to your render. No, entity doesn't have a render. Never mind. Here, right here. So the entity, you make sure you have a shader parameter here. We don't define it because it's pure virtual. You don't have to define it. So I removed the definitions from the bottom. Anyway, this is very simple, right? Just have it like that. And the get center part is important. I made a get center. It's very important that it's not a reference here. All right, it's very important. I know a lot of you might miss that. So not to call you dumb or anything. Anyone could miss those. It's just that it's a small detail. So that's why. Wait. Might have missed something here. This attribute component equals null. Okay. Missed that from before. Make sure you have that. Anyway, all right. Make sure you have that. All right. Anyway, let's keep going. So the get center is kind of complicated. Or not complicated, but it has a lot of code. So make sure you're dividing the global bounds of the hitbox component, width and height, with 2, and then adding that to the position of the hitbox component. Okay? You can pretty much do it like this if you want. Whatever helps you to see what's going on. Okay? It's the same thing here, but here you want to use sprite instead. Okay? Done, done, done. And that's the get center. So that's going to give you the center point of the player. Now, game state is very important. Lots of changes here. Okay, especially how we render stuff. So you see we're sending in different things. But let's start off by checking this out. Your initialize shader function. This is the first part. Init shader. So remember this. You're loading it. Make sure these file names are correct from what you have. 100% make sure they're correct. Otherwise, you're going to have issues. Am I recording? Yes. Okay. .vert.frag or whatever you have. This is basically a text file. You can have .txt if you want, but this makes it easier for you to read it. Okay. It's not that strict. Just make sure this is exactly like your 2 files here. The names of those files. But anyway, once that's loaded, it shouldn't give you any error messages. Okay. You go down. We can use tile sheet here, tile sheet 3 here as well. Anyway, it doesn't really matter since this loads the correct tile sheet it needs. Anyway, don't forget this, all right? Init shaders here in the constructor. Don't forget to call this. Very important. Otherwise, you won't load the shaders. Okay? Make sure you load it. And once you do, you go down to wherever you render stuff. Let's start off by the first render here. So we're rendering the tile map here. Right here. Make sure you send in the player's grid position, the core shader as a reference, the address to the core shader, and the player's center, and false for showing collision, I think. Yeah, but these 2 are new, all right? So make sure you send those in the right position. When you render the player, same thing. Send in the core shader, and that's pretty much it. It will take care of its own position by itself. Deferred render, same thing. Send in the player's position that you want to render the light from, and the core shader reference. Soon we're going to go through the shaders themselves, but this is just to make sure you guys are on the right page and we have the same code. So that's pretty much all you want there. Game state, make sure all this is done. Nothing special here. All good. Fragment shader, we'll get to that. Tile map, okay, tile map render. This is where the important part is. These 2 parameters should look exactly like this, okay? Pointer, and not a reference here. Not a reference to player position. Very important. And once that's done, make sure you have your if statements for if you have a shader or not to render them in these 2 different ways. Same thing for deferred render. Right here. The if statements, if you have a shader or not. Okay. Tile map. Here you have your default parameters. So these 2 should have default values of null and vector2f empty. Okay, 0, 0. Same thing here. Null and a regular vector. Okay, those 2 things are very important. So once that's done, the editor itself will render with, when you render it in editor state.cpp, just send in null here and send in vector2f empty here. Okay, very, very important. So you get something rendered in editor state. Otherwise, you're going to get errors here. So make sure you do that because you might get errors here if we didn't talk about it enough in the last video. Now let's get to the shaders. So let's start off with the first part of the pipeline, graphics pipeline. That's basically the Vertex Shader. So this takes all the points from your primitive or your square. In our case, the 4 points of the square. Actually, it's 2 triangles, but yeah, it's about 6 points then. It's 2 triangles set together to make a square. Basically, all those points come in here, shooting in here like an array into the Vertex Shader to be processed by all the small cores in your graphics card. Okay. And what's going to happen is we're going to basically come into the void main of that program, this shader program. We're going to transform it with something called a model view projection matrix. You don't need to think too much about this, but it's basically a matrix that takes this position and it converts it into a world position in the world. Otherwise, it's just going to be a position on the screen. You want it to be on the world since we're using views and everything. So the view is basically our camera, right? Projection, you don't have to think about too much in this. We're not making a 3D application, so it doesn't really need to be anything special. Just don't care too much about that. But you need to multiply this with your GL vertex, which is the position, that vertex position, each one of those vertex positions of those two triangles put together to be your square. So all of those 6 are going to be multiplied with this, and they're going to be saved in something called just a outgoing variable here. This is something I created myself. You don't have to think too much about this. Just remember that it's a vector 4, so it holds 4 values, x, y, z, and w. W is for depth and stuff like that, so we don't have to care about that too much. Just make sure your w is always at 1, okay? So make sure that z, your z value can be at 0, doesn't matter. But your x and y is what's going to be important since we're working with 2D. So just make sure it looks exactly like this. You have out and varying. It's very important. Otherwise, it won't work. Then this GL position is basically telling this is the final position of the vertex. Okay, it's being sent out to be used by the graphics card. So it's been processed already. So GL position is an internal variable that we don't define. It's already defined. We're going to set it to tell the graphics card we're done with processing this vertex. And we're just basically doing the same thing here, multiplying its screen position with the model view projection matrix, put it in the world, convert that matrix. This is the texture coordinate, so they're pretty much bound to these positions, and you get texture coordinates is kind of like where should I pick a pixel from the texture image and put it onto this object. That's basically a texture coordinate. So just remember it's important. You can read more about it. I can't give a lecture on this really just yet. I do talk about these in my 3D OpenGL videos. It's pretty much the same. You can kind of apply that knowledge here. But what we're doing is we're actually just picking out pixel positions from the texture, and we're putting them on here, saving them here, and sending them onwards to the fragment shader. So the same thing here. Anything that starts with GL underscore is an internal that we don't have to define. And we're just setting it, telling it we're done. GL front color, okay, we're forwarding this color of the vertex. So each vertex can have different colors, and we're just sending that to the fragment shader. So once that's done, these are saved. It looks exactly like this. Remember, all of this should be exactly like this. We go on to the fragment shader. It doesn't go directly here because the fragment shader is pretty much the last part of the graphics pipeline. Now you can Google graphics pipeline, and you'll see how it looks. And vertex shader is always first. Then you'll probably have the geometry shader, blah, blah, blah. But since we're using such an old version of OpenGL, we don't have all that extra features stuff. Pretty much just allowed to use the vertex shader and the fragment shader. I'm pretty sure anyway. Anyway, once we get to the fragment shader part, you'll see varying in vec4. All right, so it's an incoming varying variable of the size vec4, and it has to have the same name. Remember, it has to have the same name as this. That's how they are linked together. So there you go. Once you have that done, we'll get that from the vertex shader. Now, our uniforms are kind of stuff we create ourselves, like I said in the last videos. Variables that we get from the outside program, from the processor, CPU. All right, remember, these are all run in the graphics card. This is stuff we get from the CPU. So we get the texture, all right, the image, texture image, basically, with color values for each of the pixels. And we're going to use that texture coordinate thing we got to combine it with this texture to kind of print and paste this texture onto our object. So that's why we use those things. This is just a Boolean I have to ask the CPU basically if we have a texture or not to render even. If we don't, we're just going to use the regular GL color that we got from just a basic color. And then we have the light's position. So we're going to have several lights later, but this is just a test. So don't worry too much. This is just one light where we're going to say, okay, this is where the light originates from. All right, let's keep going. So ambient light is going to be the light that is kind of always there, no matter what. And it's going to be very low because, at nighttime it might be low. In the morning it might be 1 full. Okay, and remember, colors in GLSL, the GLSL shading language here, doesn't use 255 as a max value like SFML does. It uses 1. So 0.5 would be half, and 0 would be none, and 1 is max. Okay, this is the alpha value. This is the red value, green value, and blue value, and alpha value. That's pretty much how it is. And it's a very low light, very dim light, which we have in the background. Okay, so ambient light is very important. Remember to have it vec4, because we have 4 values here. Now we're going to convert the light position to the world position. Okay, so we just multiply it with this GL model view projection matrix and itself, basically. Now this might seem complicated, all right? I know it will. But basically what I'm doing is I'm converting this light position, all right? Since it's a vector 2, remember it's a vector 2, I'm making it into a vector 4. So this is how you do it. If you want to make a vector 4 out of a vector 2, you put it in here, so the x and y values will be set, and the z will be 0, and the w is 1. So these are actually 4 values, even if it seems like 3, since this contains 2 values. All right, so it will become a vector 4. We multiply it with this, because this can only be multiplied by a vector 4, okay? Once that's done, we kind of say dot xy to just get the x and the y values from this, the whole calculation. This will be created into a vector 4 itself, and we just get the x and the y values from it. So this is called squiggling or something. I don't remember exactly what it's called, but you can kind of get 2 values at once and put them into the light position itself. All right, so that's how that's done. Once that's done, that will be saved in here. Now we got to calculate a vector, so a line pretty much from the light to the vertex position. So the position of the fragment, the pixel, you want to get the distance between that pixel and the light. And what happens is it's a very complicated process for those of you who don't understand shaders yet. I don't want you to stress too much about shaders. I just want to use you to use this shader, copy code, and then read about shaders later. Okay, remember that. But what happens is, remember, the Vertex Shader processes 4 points, and it sends them to the Fragment Shader. But here, this is gone through a process called interpolation, which kind of generates values for each of the pixels within that object. And they'll have their own vertex position. So each fragment, each pixel, maybe there's 64 times 64 pixels, right? Each of those pixels will have their own value of position, since we sent this in here. And we can use those positions to kind of calculate the distance between the light and each of the pixels. Once you do that, also, it will be oval because our resolution is kind of weird. So don't mind this. This is just going to kind of take that value and increase it so we get a circle instead. So you can play around with this value, play around with these things here, see what you get. Anyway, then to get the length, there is a length function in GLSL. So we're just going to get the length of this vector, so how long it is. We're going to clamp it, meaning it will have a minimum value of 0 and maximum value of 1. We don't want it to go above 1. You'll get some weird lighting values and stuff like that. So just have between 0 and 1. We'll multiply it by 4 to shrink the circle a little bit. The more you multiply it with, the larger or the smaller the circle is going to get. Remember that. So you can kind of use this to say how strong you want the light to be, or how far reaching you want it to be. And then 0 to 1. Good. We'll do this texture coordinate thing. Don't think too much about this. This is where we kind of paste the texture onto we get a texture, the pixel color of the texture at that point. Okay, that's basically what we're doing here. So we got the pixel here from the texture. If we have a texture, we're gonna say the final color. This is the internal variable here. The final color is the color we got from before, the GL color of the vertex, multiplied by the texture color here at that pixel, multiplied by all the lighting. So this is all the lighting. We clamp down the ambient plus the light from the circle. We clamp the whole thing down to 0 to 1. So we don't want this color to be more than 0, less than 0, or more than 1. Okay? And we're saying basically -1 minus the vector's length. So how far away I am from the point or origin of the light, minus the maximum. All right. So that pretty much gives me a value in between. I know it's very complicated. I'm still explaining it for you guys just so you know, but I don't expect you to understand all of this just yet. But just read the code, try to work through it. I know it's hard, but in worst case, don't care about this too much. You know what? Don't care about all this too much. Just go with it. Just go with the flow, use the code, and you'll get some lighting going. Otherwise, just think about it. Think what I'm doing here. Read up on shaders, and you'll pretty much be cool. You'll pretty much be good to go. So that's it, guys and girls. Hopefully, it's working for you. And we'll run this code just one more time for you guys. And new game. And you'll see that you have your light here. Okay? So I want you to play with these values. This value specifically, and this multiplying value. Okay? And remove the clamps. Try playing around with those. But there you go. Hopefully we didn't get any errors or warnings. Yeah. Thank you so much for watching. Keep working hard. Thanks for all the support. Take care. I'll see you guys and girls in the next one. All right. Bye-bye.